Hello, in this video let us solve this question. So we have t power of t is equal to 9. So here, to solve for the value of t, that satisfy this given equation. Now, in this sense, or to look for a particular number that once raised to that same number, it will give us 9. Take for instance, if you have 1 raised to power 1, this is equal to 1 and this is not equal to 9. Okay, if we try 2 power of 2 is equal to 4 and 4 is not equal to 9. Moving on, if we try 3 power of 3 is equal to 27 and 27 is also not equal to 9. But looking at it, right, if you raise 3 to the power of 3, it will give us 27, right? And 27 is greater than 9, the value we're looking for. Also, if you move upward to 2 power of 2 will give us 4, and 4 is less than 9. So, in other words, we can say that the value of 9 is in between 2 and 3. So, 2 and 3. But if we are to look for the exact value that will give us 9 once raised to the same number, right? If we're trying it, okay, let's say we try 2.1 up to 2.2, then so on and so forth, it will take us time. But then to solve it easily, right? This is how you can solve it. So, solution. First, we have t power of t is equal to 9. Now, what we'll do is that we'll introduce natural logarithm on both sides of the equation. So, ln t, the power of t, is equal to ln 9. Now, take note that ln is equal to log to base e, while log is equal to log to base 10. In other words, ln is also log, but to the base of e. That means that we can apply the property of logarithm to natural logarithm. Now, we will have a rule that if you have logarithm of a, power of b then becomes b times the logarithm of a. So applying this rule to this natural logarithm right here, what you have is that power t right here then becomes t, then you have times ln t is equal to, you have ln 9. Now, t times ln t is t ln t is equal to ln 9. At this junction, right, or to solve for the value of t. But to solve for the value of t, what we'll do is that we'll introduce what is called the Lambert W function. So we call it the Lambert W function, or it's also called product log, or it's also called the omega function. Now, what exactly is this Lambert W function? Now, take for instance, let's say you have an equation. Let's say you have a times a power of a, right? If you apply the Lambert W function to this equation, what you will get is a. Also, let's say you have y times e power of y, right? And then you want to solve this equation. If you apply the Lambert W function to this equation, what you will get is y. Okay, so we're then going to apply the Lambert W function to this equation to solve for the value of t. But to do so, right, what we'll do is that we're going to introduce this, that if you have e power of ln x, right, is equal to x. Why? Because e, you cancel ln, your x stands alone. Same thing also, if you have e to the power of ln t, right, if you cancel ln and then your t stands alone. So in other words, we can replace t with e to the power of ln t because it will still give us back t. Now, applying this right to this t right here in place of t, what we then have is that we're going to have e then ln t, which replace t then times ln t right here. So ln t is equal to, you have ln 9. With this, we are then about to apply this Lambert W function. But then looking at it, this e to the power of a is in the second place, right? So that means that we will switch this to be in the second place. So we're going to have ln t then times this, then becomes e power of ln t is equal to ln 9. Now, since we have this, we can then apply the Lambert W function. Now, if you have w, right, then in bracket ln t times e to the power of ln t is equal to w, then in brackets ln 9. Okay, so with this, to then solve for t, what we'll do is that if you apply this lambda w function on this, length t times e to the power of length t, what you have is length t is equal to lambda w function w in brackets length 9. To then solve for t, we're going to eliminate this lane right here. And to eliminate this lane, we will bring in e to the both sides of the equation. So e to the power of lane t is equal to e to the power of w, then in brackets lane 9. Shows that e will cancel lane and t stands alone. So t is then equal to, we have e to the power of w in brackets lane 9. And this is the value of t. But if you are confused as to why the value of t is not a decimal number, now in your calculator, if you press e, then you will not see w, you will not see the lambda w function in your calculator. Instead, you will press product to log, right? If you press product to log, then in brackets lane 9, what you will get as the value of t will equal, if you press this in calculator, you will get 2.4510. Now, if you get this, shows that working back to our equation, if you raise 2.4510 to 2.4510, you will get approximately 9. And so the value of t that will give us 9 is 2.4510. I hope you all enjoyed the video. Don't forget to like the video, share the video to your friend, and please don't forget to subscribe. Subscribe now. Thank you very much. See you in the next video. Bye.